So, welcome to this introduction to Azure Cloud Architecture Framework. My name is Johan Ludvig. I'm a Norwegian guy working for Capgemini in Norway, so I'm a solution architect. These days I mostly do PowerPoint instead of actually doing hands-on, which is a bit of a problem for me, but at least I can spend some time in Azure in my spare time. But I wanted to talk to you about Azure Cloud Adoption Framework, which is a set of best practices and principles. So this will be a very slide-heavy introduction or presentation. I will try to show you a bit how we deploy things, but in the end, part of it I can't do because I'm not allowed to run on the level of tenant access I have. So we'll see that when we come to that part. And since it's my first presentation doing with Macintosh, with an Apple, I might struggle a bit with Zooms and so on, so please apologize for that in advance. I have also not included any contact details in the slides, but I will add them later on, so when you download them, if you want to, you can reach out to me with on Twitter or on email or something else. And cute, fancy logo. So, the agenda is, how many here have worked with infrastructure as code? Quite a few, good. How many of you have used the Cloud Adoption Framework? Excellent. At least that means I'm not completely off. It's a very basic introduction, so I will be going through why infrastructure as a code, just some basics as well. Then again, Cloud Adoption Framework, looking at the cloud foundation part, which is not something that's... how many here are infrastructure guys? None, yes. Because that's something that we data people don't normally touch, because we either set that out off to somebody else or it's already been deployed. But it is important to understand the basics of this, and I will cover it a bit, and then we'll dive deeper into one of the scenarios of several that Microsoft has deployed. And we're going to look at what's called, it's not, I've forgotten to update it here. They changed the name 2 weeks ago. I've changed everywhere but in agenda. It is the Cloud Scale Analytics scenario. So of course, everything that you do in the cloud is code. And you can do code in Azure using ARM, so Azure Resource Management. You can use Terraform, which is HashiCorp implementation of infrastructure as code, and that is probably the most used in Azure today. And then you have Bicep, and Bicep is a new-ish language from Microsoft that is more of a declarative version. And then all the different Cloud Adoption Framework baselines are available as templates in all languages, which means at least the Cloud Foundation parts that we're covering today, you can go and download into whatever language you prefer to develop in and start testing on yourself. So first of all, we have ARM. As I mentioned, that's Azure Resource Management. It is the core of all Azure services. So every time you go into the portal and you choose to have a SQL Server deployed on the VM with an image, everything that happens underneath the hood is being done using an ARM template. It is JSON, which means that it is quite chatty, it's quite wordy, and it's a pain to go through. But everything that we do today, everything we see today is available, again, because this is the baseline of Azure. Then you have Terraform, and Terraform is an open source project delivered by HashiCorp. It is open source in that you can, of course, also buy the freeware or buy the premium versions with support. It is very popular. It is multi-cloud, so you can run it on all the different hyperscalers. And it is a declarative language, even though it is still quite wordy. And you can create modules with it, unlike ARM, where you can describe each and every resource into one huge giant template. you can create modules saying, okay, I want to have my SQL service described here, I want to have my storage accounts described here, my network described here, and then I can deploy that out by picking and choosing the different modules I want. And of course, when you compile it, it will generate ARM templates because that's, again, the core of Azure. The problem with Terraform is that if you're going to using the latest and greatest services, they might not be available in Terraform yet. Sometimes it takes a week, sometimes it takes a month to get that new service into Terraform. The benefit, though, is that there is a new model out that allows you to take an existing resource. For instance, if you have Purview and Purview wasn't available in Terraform, you could deploy it manually, and then you could script out the Terraform code afterwards, which is quite nifty. Then you have Bicep, and of course, I guess you have taken the pun already on ARM and Bicep. So it's the new language. It is only in 0.4, at least when I checked last time, might be 0.5 now, but it's still, if you just run and develop resources in Bicep, you can just as well develop them in ARM. But the challenge or the benefit of Bicep comes once it's a declarative language, so it's a bit more powerful and you don't have to write as much code as you do in ARM. Secondly, you can create modules and libraries, which means that you can take the whole cloud scale analytics scenario as one huge library, or you can dive into the different modules and pick the one that you want and then deploy them out in pipelines. And of course, this also generates ARM. And because it is Microsoft native, it should allegedly support all Azure services. Though because it is still 0.4, it's truth with modification. So this is just an example of how a deployment pipeline with modules and libraries in Bicep can look like. And this is again from a landing zone perspective. Let's see if we can get it working. Oh yeah, it's a bit there. So you start off by rolling out your management group modules, custom policies, RBAC roles, then logging and security, hub networking, RBAC roles, subscription placement, policy assignments, and so forth. And again, all these are modules, so you can pick and choose which one you want. And because you can download everything in a zip file and then start developing on it, if we just switch to... Did I get it? No, I didn't. It was on the wrong... Oh, that's... It's splitting the screens. So, let's see if I can get this... Yeah, my Zoom wasn't working. Is it really working now? No, it doesn't. Well, the thing is, this is Visual Studio code. I guess you've seen it before. And I've downloaded the whole library of the data landing zone, the base modules, as code. And then I can start writing and adapting it to my own environment, removing things that isn't interesting because I'm a small business, or adding more security baselines, adding some custom hardware, for instance. I don't want to use Microsoft firewalls, I want to use Trend or something else. And then I can replace that and store it in my GitHub account, build my pipelines, and then whenever I want, deploy that out. Of course, if I try that now, and again, I need to pull this one over for you. Okay, maybe the easiest way is to actually just, if I do that instead, can I get to show it to you? Yes, I can. Perfect. So the thing is, as you can see, hopefully somewhere, no, we don't. You need to deploy the baseline, so the cloud foundation part of Cloud Adoption Framework. You need to have a certain level of access in your tenant. And because I'm running a Visual Studio subscription here, I don't have that kind of tenant access. That's something that Microsoft controls. So I can't really deploy this. It would have been fun to show it to you, but I can't deploy this here for you now. But as long as you have the right access on your tenant, you can then roll things out. So going back again. Yeah, this is where the demo appeared. I tried to show you. So Cloud Adoption Framework is Microsoft's best recommendations and tools and blueprints and best practices rolled into one. It is a gigantic repository of documents and GitHub repos for you. And it builds on top of WAF. So another three-letter acronym, but the well-architected framework are the architectural principles and best practices that Microsoft recommends you to follow when you implement an Azure topology. And one of these is, of course, you need to think about network, you need to think about security, you need also to think about costs and cost management. Because if you don't put guardrails in place as you roll out your foundation, you will have consultants coming in, playing around with things, and then leaving after 6 months or a year, and didn't follow the best practices on naming conventions, and forgot to turn things off. So suddenly you have an AKS cluster with 100 cores running, costing you thousands of dollars a month, and nobody checks until you get the bill. And of course, you will find a well-architected framework and a cloud adoption framework with different namings in all the different cloud vendors. So Google has it, or Amazon has it, but of course, Azure is the best. And again, it takes you through these patterns and recommendations, starting off with defining your strategy. What do you want to do in the cloud? Then starting to plan your digital estate, because lifting and shifting, while that is for some reason a recommended approach from Microsoft, is not really the best option. If you have to, sure, but you won't get the best bang for the bucks by shifting your on-premise to the VMs in the cloud. You get the best cloud performance by redesigning and re-architecting your solutions to adapt to a cloud-native world. And this is where the planning comes in. And then we have the ready phase, and this is where the Cloud Adoption Framework, the code and so forth that we're talking about today, is situated. That is when you start doing that. So select your operating model, and it again depends. What I'm going to talk about today is enterprise scale, because that's what Microsoft puts out and pushes, because that's where the money is, of course. But you can go and select different operating models defined on your organization's needs, whether that be decentralized operations, central, enterprise, or distributed. And you will find recommendations on all of these, even though most of the patterns and blueprints are enterprise scale. Now, I suspect most of you have covered it, but I thought I'll talk about it again, because when we are talking about Azure, we have a hierarchy of functionality. So you have the tenant, which is the top one. And the tenant will be something like, for instance, in my Visual Studio, it's Arabian Gmail, which is my Gmail account, .onmicrosoft.com. So that is my tenant. Underneath there, you can have management groups. And these management groups can be one or many. And under these management groups, you have subscriptions. And the reason why you have grouped it like this is because you can have a set of policies that are enterprise-wide concerning everyone. And then you can have policies that are on a group of subscriptions or functionalities or group of departments. And then you can have subscriptions policies that are running only on subscriptions. So this way you can trickle down and control over a whole wider area than if you had just run for single subscriptions. And then, of course, you have your resource groups and your resources underneath there. And it will look something like this. So management group is the top level, if you just ignore the tenant part, and then you have subscriptions and resource groups, and typically you want to have a lot more subscriptions than at least I, when I started out, thought was sensible, because you could put everything into resource groups. Why should you have subscriptions? Well, there are different reasons why, and one of them is, of course, a better granularity of control on costs and so on. And when you scale this up to enterprise scale, you will get business units. You can even have top management groups over there again, geography, environments, so prod, test, dev, and so forth, and then subscriptions under there again. And when we're talking with infrastructure guys, that is, in my world, I'm talking about data platforms a lot. And when I talk to infrastructure guys, I say, platform what? In their world, a platform is this entire Azure tenant. All the services that are lying there, that's their platform. So it's smart to, when you talk with them, to just clarify which platform you're talking about. Then you have landing zones. And again, in my data world, I'm talking about data landing zones, so where I land my data, either in the cloud or in the data warehouse or whatever. But a landing zone is a bit more in Azure. So your landing zone is a set of services to be an entry point or a staging point into your Azure environment. So it's a landing zone. So an environment for hosting your workloads provisioned through code is a bit simplified that way. And that is your target architecture for your cloud environment. And typically we talk about the landing zone as the first stage you get to when you travel, say a data packet travels from your on-prem SQL server to Synapse or to Power BI, it will go through this landing zone on the way. That's this first part of its cloud journey. So it's scalable and it's modular, and you have some environment design areas that you need to think about when building this data, this landing zone. So again, building an AD tenant, where should I put these things? What kind of identity access management should I use? What network topology do I need? Do I have any resource groups, security, management, governance of the whole thing? And of course, DevOps and automation. And of course, again, billing and cost control is really, really important. And it is, even though it's on the top left here, it is the most ignored part in all the Azure subscriptions and environments I run into. So, and you can have different landing zones for different kinds of applications, or you can have one central landing zone and then just spin off the different subscriptions and systems that you need out of that one. And it confusingly looks something like this as well, because the landing zone in itself might be a set of subscriptions depending on the scale of your environment. So an enterprise scale can have the central governance, a networking hub, which is one subscription. Then you have security, Sentinel, that kind of thing, in one subscription. Again, trying to separate as much as possible to make sure that you can fine-grain your security controls within that. And again, because in the cloud, you can't really fence in your data center. Everything has to be built into layered security. And this is where the demo should appear, but I'm skipping this one because I showed that earlier as well. Right, then we have hubs. And hubs and spokes coming forward, that is the common type of pattern in your architecture in the cloud. So you have hub and spoke. So that's your core is the hub. That's where you have your common services, networking, connection to your on-prem environments and so on. And the spokes, that's where you have your application or function-specific subscriptions and resources, where that is data services, API platforms, and so on. And it will typically look something like this. So you have your on-prem environment, VPN or express route connection to the cloud. Then you go through that landing zone, which is your central hub. And you typically have firewalls on each place and so on. And then you spin up the different environments into these spokes, which are then subscriptions. And typically you would like to have both the dev and the test hub spoke system. But that also varies on how much you really want to put into this, because you can of course have just dev and test subscriptions connecting through a central hub, depending on how your network topology is on-prem and in the cloud and so on. There are some really cool tools as well to help you along the way. I think one of the most important ones is the Azure naming tool, which helps you build the naming convention you need, because there are, I don't know how many of you have seen trying to name conventions on storage accounts versus SQL servers versus something else. Some allow lower cases or upper cases, some allow dots, some allow dashes, some none. So having a tool that helps you and guides you, that is really practical in that way. As well as, of course, you have your various templates that we're going to talk about, and the blueprints. And these blueprints and templates are what we are talking about now. So Microsoft saw that, okay, we have the cloud foundation, which is nice, it's important, it is a baseline for everything we do, but our customers also like to speed up the deployment, at least of the dev environment, so they can start working. And because in a modern world there are so many different moving objects that you need to think about, so let's give them some blueprints so they can get started right away. Of course, being Microsoft, they also then boost everything up to full to make sure that they get the most credits running for this. But it is fitting into the same pattern of planning, estimating, getting ready, and then deploying, and supported on their best practices and recommendations on security and networking topology and so on. So the first of these scenarios you have, I think there are 6, is a VMware solution. So again, how to deploy on-prem VMware into Azure. Then you have a hybrid and multi-cloud environment. Again, all the different solutions you need to get into that operating model. Modern application platform, which is how to run microservices in cloud best practices, but also how to run API or integration platform kind of approach. Then you have SAP on Azure. There is a retail industry specific scenario. And then there is a cloud scale analytics, which is the one that I wanted to talk about today. And of course, again, all of these are enterprise scale focus, which means that if you're doing a smaller business and trying to download these, take a look at each of the objects that are in there and remove the things that are not suited for your needs, or scale down to a version that is closer to what you need, instead of having, for instance, a Synapse dedicated SQL pool. You can just have serverless SQL. Yeah, remove that one, or at least scale it down to 100. As I mentioned, modern data platforms consist of a lot of moving parts. This is reference architecture from Gartner. And you have, as you can see, there are lots of, you have stream, you have on-prem systems, data access, data visualization, storage accounts, networking, cluster management for Kubernetes, and so on. So it gets harder to think about how to design your platform compared to your old on-premise version, where you had a SQL server, or you had a Teradata or a Netezza box, and all you had to think about was, okay, how many cores do I need to buy the license? Likewise, Capgemini has a reference architecture. It seems to be quite confusing because there are so many different boxes, but it is trying to tell you to think about what kind of capabilities do you need. The platform foundation, so the purple layer underneath, is where you have your cloud foundation parts, which I mentioned from earlier. So operations, monitoring, security, IAM, DevOps, that kind of thing. In the top layer, you have governance, which is data catalogs, business glossaries, master data management. And in the middle here, you have the more classic data things like storage, enterprise data warehouse, APIs, data modelings, facts and cubes, and all the way out to reporting and data science. And it doesn't say that you have to have all of these components. It's just that you need to go and think about, do I need to have data science? Do I have machine learning models? Okay, if I have machine learning models, I should, sorry, that's the wrong one. I should think about monitoring. I should think about data science workbench, orchestration, model catalog. And model catalog is because you want to make sure that the one that is deployed in production for machine learning is a current one, but the score that the client got for credit loans 2 months ago was not scored on the new one. So you need to track down to see, okay, which model version was I running? And that's what the model catalog does for you, at least part of it. So these, again, it's trying to help you to find out which capabilities you need in your data platform. And of course, yeah, I forgot to mention that data lakehouse, data mesh, hot topics, everybody's talking about them, data fabrics. All the marketing departments are running around clamoring that their services are supporting XY set of these buzzwords. But again, it's another complexity to think about when you think, okay, I want my data platform in the cloud. What architecture should I go for? But again, this is why, while the complexity of the architecture decisions increase, infrastructure as a code, everything is code, the templates that you get means that it is a lot easier for you to gain control and keep control over your architecture these days, because you can have everything sorted in GitHub with version control and so on. And it is also a lot easier, say that your management wanted to have both dev, test, QA, and prod environments, but at the same time, that's so expensive. Well, QA might not be needed more than, say, 12 times a year, depends on your release cycle. Test might be needed a bit more often, but still, you can delete those afterwards and deploy them again and copy data over. You don't need to have them running 24/7. They can be just lying around in a repo as code and then rolled out when you need to deploy a new version. So these are things that you can do now that you couldn't really do before. And of course, because you have these scenarios and accelerators, you get help to build these things. And the cloud scale analytics starts off with, again, landing zones. Microsoft are horrible at naming things, but data management landing zone. So one of these in each scenario, and then X number of data landing zones, and within the data landing zones, you have data products of various sorts. And these are, let's see now if I can get here again, because this I'm allowed to deploy. So I thought I'll just guide you through what I've done. So now I've just taken the baseline deployment from Microsoft's GitHub. Selected my subscription, where I want things located. Again, for the landing zone, which subscription I want. Prefixes as well. And then password for the different workspaces. If I want to use Bastion, which is the best approach if you want to have development in Azure. Then tagging. In this case, it's not really important because it's a demo environment, but for billing purposes, it's very nice to have put in ownership of that, and that's also something you can do with policies, demand that they are filled in. And then it is reviewing it to check if it fits with all the policies, and then it is create. And it's now started deploying. And while it is deploying, let's move on. I'll just double check if there wasn't anything stopping. No, it wasn't. Yeah. That's the benefit of having a demo subscription. I don't have to care about the cost that this is incurring. My credit card would not like me, and my wife. So, cloud scale analytics is targeting data mesh-like patterns. They state themselves that they want to push data products or data as products. How many here have heard about data mesh? A few. Okay, data mesh is a quite new thing. It is an approach that tries to make data and analytics into a microservice approach. So you build, instead of having a central team that does the ETL and pushes things into a central data warehouse, you split this up, give ownership of the producing of data, and to either to the source or to the business side, to cross-functional teams, and they will build and own and manage the data that they either want to provide to other users in your company or that they want to consume themselves. So this is a very split up fashion, but again, it tries to look at data as your central component for your organization. Instead of just being a byproduct, it is actually something to give you value. And there are lots of different discussions on data mesh going around. I'm not going to dive deep into it, but let's just say it's more about people and processes than on technology. You can build a data mesh on any technology you want, but they are pushing it here, of course, because it's a hot topic. Again, this is open source code. You can download it and do whatever you want with it. You can adapt it. If you want to have data product focus, fine, do that. If you don't want to, you can remove those parts and add something else. Microsoft wants you to go around and play with their code and do whatever you want with it. There are 5 basic modules in this. So the first one is a data management zone. Then you have the data landing zone, or several. Then you have data integration batch, and then data integration stream. If you look at the GitHub repos, these are named products, but they aren't products, they are more common services. And then you have the data product part, which is analytics and data science. And the data management zone, let's start with that. That is, again, one per scenario. You don't need more than one management zone. And it creates one subscription of your central hub. And all management services, at least the ones that Microsoft define, are deployed in there. And this is just architectural drawing of this, but it means that you get either you connect to your central IAM solution or Azure AD, or you create your own here. You can have DNS zones, you have your data catalogs, your key vaults, API catalogs, you have Purview, of course, because that is the data catalog, microservices, Kubernetes, container registration, and so on, and networking, network security groups, and so on. So it's all the things that are core management services. Then you have your data landing zone. And the data landing zone is a one-to-many, so you can have 10 if you want, or 20. It doesn't matter, that depends on what your needs are. And that is your central subscription for persisting data and running your workloads. So that's a single subscription or many subscriptions doing, again, if you want to have data mesh kind of architecture, you want to have multiple data landing zones depending on the domains in your business and the various operating models of your product teams. You get storage services, ingestion services, so again, Data Factory or Informatica if you want to do that. Management services, again, so networking, monitoring specific to the solutions that are within this data landing zone. And it might look something like this. It's a bit bad resolution on this one, but it's again, basic networking, key vaults, monitoring solutions, data lake services. If you want to have a data lake house architecture, you have bronze, silver, gold data lake storages, or raw data lake with layered patterns. Then SQL DBs if you want those, common and shared ingestion patterns. So again, if you want to use Databricks or Synapse as your ingestion and transformation tools, you can have a shared workspace for that as well. And then of course, all the different patterns for ingestion further on, such as event hubs for streaming and so on. Then 3 and 4 are quite similar. It is a data integration, either batch or stream. And again, it tries to give you as many as you need. You don't have to deploy one, you can have 20 or 100. And these are deployed as resource groups within your data landing zone. And these also come with a set of storage services that are connected again to the specific need for that data integration scenario that you're deploying. Data orchestration, whether that is Data Factory or Event Hub and IoT Hub, or you can use Synapse or Databricks. All are options that you can fiddle with in this area. And the same thing with transformation, whether you're running mapping data flows, though I don't know why you would, Synapse, Databricks, Stream Analytics, and so on. And of course, the shared runtime services that the different services need to connect to your on-premise environment or other sources that you're connecting to. And of course, your metadata stores. It's a bit simpler this way. It's few resources, but again, they are trying to put these into more specific, role-specific resource groups. Then you have your data products. And again, data products can also be as many as you want. And they are deployed as resource groups within your data landing zone. Of course, here as well, if you're running in full-blown data mesh, a data product should be as independent as possible. And feel free to put the code that says a resource group and create that into a subscription instead, if that what fits your patterns or your architecture. And you get shared workspaces for Synapse and Databricks in these, as well as, again, key vaults connecting to these, and data science services. Typically, they want to push Azure Machine Learning and Azure AI services in here, but you can also adapt them to your needs. And this is either you call it data mesh or independent data squads or teams. It's a pattern to support those kind of needs. And from a data mesh perspective, it says shared here, but that's typically then for each separate data product, you have these set of services that are shared within that data product. And this is, again, something that you want to see to have a fine-grained control over cost in your organization. So either they are different teams that need to pay the cost or different organizations, departments and so on. You can tag that down to the resource level in a lot stronger fashion than you can if you have everything into one single one. So let's see, have we gotten a deployment ready yet? Doesn't look like it. See if I have. Oh, it's still not running. Okay, let's see if it is done before I end this session. Otherwise, we will just have to live with it. So, Why should you use Cloud Adoption Framework in general? And specifically for this scenario? Well, again, baseline infrastructure, policy services, best practices, everything packaged to you. Sorry, I'm clicking the wrong button. Giving us basic common language to talk to your infrastructure engineers. Sometimes it is not, you don't have any infrastructure engineers in your environment. You might need to hire somebody in to help you, but at least they will know what you're talking about, and it's a lot easier to get cooperation from both sides. When you're building infrastructure as code, it means that you can do CI/CD on the whole pipeline. I've been running in companies where when I needed a subscription or a sandbox, I could just post a message on the Slack channel saying I needed a sandbox with these kind of services, and half an hour later I had that delivered with me as an admin on it. And it was tagged to my department and for all the costs and so on. So it's a lot smoother when you can start building these kind of deployment pipelines where you can check off the different modules you need and bam, out. And again, if you need a QA environment, you can delete it after it's run for this month and then deploy it again end of next month. I mentioned cost management again because it's so important. And it is giving you a fine-grained control on cost on all the way down to the single resources, and that is very important, at least from management's point of view. And these patterns support different architectures, whether it is data mesh or data lakehouse or data fabric or you name it, you can have support for that with these blueprints. And hopefully it's easier to get your bosses to understand why they need to invest in Azure when they can start looking, or if they can start looking at data as a product instead of just as a cost center for them. And getting that code into your repository, making the changes you want, saving that. If you're a consultant, that means you can build your own library and set of tools. And that's quite a good selling point when you go out to clients saying, okay, my competitor does this in 3 weeks, I can do it in 1. And just adding another huge layer. This is Microsoft's, one of their takes on data mesh, what they call the harmonized mesh. So having your central hub and then have independent data landing zones with data products serving different users and different needs and splitting them out to create that, that mesh. It's one of several patterns they have, but it's it means that you can do everything on all of this. It can be created with a single set of architecture slide, or not slides, but templates and code. And I was done a bit quicker than I thought. Let's see if we get. It's still running. Okay. Are there any questions? Yeah.
So, what's your opinion about creating those team resource groups? Because you would rather use expensive tools like the Databricks or Synapse. I think it's like more reasonable to share it between rather than create one per team or per product.
Have you tried doing source control on shared workspace with 10 teams in Databricks or Synapse?
Yeah,
the main problem is exactly that, in my opinion. And the workspace itself doesn't cost anything. That's not where the costs are. The costs are in the clusters and the compute power. So you can have, ideally I would like to see that you can share the clusters better between the teams and the different workspaces. from the signals I see from Databricks, that's where they're moving. But I'm not sure if they're there yet. I haven't tested. But because of the way that Databricks and Synapse, or Microsoft in general, are implementing source control and CI/CD on their data products, you need to have separation. Or you don't need it, but if you don't have it, you will run into problems. That's the same thing with data factories. One of the nightmares of data factories is that you have one single fat pipeline for all releases. I don't know why it is, but it is the way it is. So that's why I recommend that you do a separation as much as possible, and rather cut down on the cost on the compute power that you deploy on the different workspaces.
What about security related things? Like when you want to open the internet, it's not like you are within the network. You want to store some data from outside. Would you rather have it open in each resource, like cell-phone integration one time, or you would keep it somewhere outside and then
Yeah, I would rather have force all connections that are external through the data management landing zone, and then into the landing zone that you need exposing via private endpoints, because then you can have a firewall in place before that to monitor the traffic. So that's would have been the best approach. Even better if you could have, if it's APIs, put an Azure API management in place in front of that, because then you have a web application firewall as well into this. Yeah, that of course the main relation in a data mesh is a central catalog or marketplace. If you're doing that in Azure, I would have probably picked Purview. But again, the most important part is that the products are visible somewhere and that they can be reached afterwards. But for data factory in the data mesh setup, I would probably have gone for, again, each data product having their own data factory, but sharing the integration runtimes, because those are the cost drivers, at least in my opinion. That's the challenge, to get them to have a common set there, and maybe even have hidden common data factory underneath that they then pour into. But if I could have chosen which data transformation tool I could use, I would much rather go for Databricks and Data Lakehouse, sorry, Delta Life tables, even though that's brand new. It's a lot better for this kind of independent thought, or DBT even. Also, it's a better approach to this. Mm. Yeah, so that is one of the main challenges for me in data mesh. So I probably haven't read all the books and blog posts out there, but specifically when you're building products upon products. But again, you don't need to have, as long as your data product is being published somewhere, whether that is a shared storage account or this is your storage account in a folder that is open to the rest of the internal company network, and then the others can connect to that because they're allowed connection to it, to pull data out and build their own product or expose it for other uses. The main important part here is that to make sure that your product is sellable, you need a marketplace. Because the marketplace, for instance, Purview, it's in preview now, but you can actually apply for access to a data set. Which means that that's a step further. I mean, Informatica and Relation and others have that already, but Purview has just a preview, which means it's a lot easier for a data marketplace to be built in Azure, because you can then expose your data products in Purview. People can buy access to it and use it for whatever they want. The challenge, of course, is what happens if that data product fails? Who is responsible for telling whom? That's organizational patterns in data mesh. Yeah.
Another question, because I was a bit scared, let's say, of seeing how many resources are currently we are working with. Because I'm thinking in terms of identity access management, and then grant resources access to either people, groups, or service principals, whatever. It's going to be really cumbersome having so many resource groups and all the resources that must access the resource group. I'm wondering where the trade-off is between simplicity and having, as you outlined, just a better control over everything.
Well, there are two patterns off the top of my head. One is how many controls mechanisms do you need? Can you have one for a set of resource groups, so just one AD group, or one set of service principals that connect to all of them? You don't need to isolate them security-wise. They can share the same resource groups, the same Azure AD groups, or you can have a hierarchy of Azure AD groups, where the top one gets nestled on the subscription level and then inherits everything underneath. Yeah. Yeah. It is. Yeah, it is a trade-off, but it's the same thing with. They are recommending so many resource groups, but it might not be you need it. It might be that, for instance, for cost control wise or for security controls, you already have everything in place, boundaried into the subscription level. So it's not that you have to have it. It's more like if you separate it this much, you have a lot more fine-grained control. So it's a trade-off. Yeah. Yeah. I have desperately tried to get on board people to into my data teams to run into the infrastructure part, because we don't have that knowledge. My last networking jobs were in, I date myself this way, but using Token Ring and Novel Network. So that's pre-Y2K. But yes, I've started to learn networking again, because there are so many things. I can't wait for a central infrastructure team to come and help me. I need to do this myself. So I either get the knowledge myself or get somebody else on my team. So cross-functional teams typically is a really good approach to that, because then you don't really have to learn it unless you like it. Any other questions? Okay, then just let's see if we actually managed to get it deployed. No, it's not. Oh well, on that bombshell, thank you so much for attending.